All right, Unit 2, Lesson 2 is on rational numbers. And our lesson essential question is, what happens when you add, subtract, multiply, and divide rational numbers? In this lesson, we'll be able to write rational numbers as fractions and identify and classify rational numbers. So rational numbers, when you first learned to count using numbers 1, 2, 3, so on, you were using numbers of the set of natural numbers, or n. Okay? When we added 0 to the set of natural numbers, the result is the set of whole numbers. So 0, 1, 2, 3. Okay? Whole numbers and their opposites make up the set of integers, or z. So any of the negative whole numbers all the way through positive whole numbers. Okay? And then any number that can be written in the form a over b, or as a fraction, where b can't be 0, is part of the set of rational numbers, q. Some examples for rational numbers are shown below. 0.87, negative 23, 2/3, negative 2.56, where the 5/6 is repeating, and 1.5. Example 1, write each rational number as a fraction. So the first thing I have is 6 and 1/6. So in order to write this as a fraction, I need to take my bottom number, my denominator, multiply it by my whole number, and then add my numerator. So 6 times 6 is 36, plus 1 is 37. My denominator stays the same. For b, I have negative 23. So any number that's just a whole number or an integer, I can put over 1. So negative 23 over 1 or negative 23 over 1. Okay? You can write it either way. For a, 4 and 2/3, I need to multiply 4 times 3, which gives me 12, plus 2, which gives me 14 over 3. For 7, I just write 7 over 1. Terminating and repeating decimals are rational numbers because they can be written as fractions. I can write 0.64 as a fraction in simplest form. Okay, so I have 64 hundredths, which is 64 over 100, which I can divide both by 4, which gives me 16 over 25. A handheld video game system weighs 9.675 ounces, or 9 and 675 thousandths ounces. Write this decimal as a mixed number in simplest form. So the 9 comes out front, so anything in front of the decimal is my whole number. Then I write 675 over 1,000. So basically, as many numbers behind the decimal is how many zeros you have in the bottom of your denominator. Then I simplify from there. So 675 over 1,000 becomes 27 over 40. Let's try it. Write each decimal as a fraction in simplest form. So for 2a, I have 84, and there's 2 numbers, so it's 84 over 100. And when this simplifies, I get 21 over 25. Most calculators will actually do it for you, and they'll actually do it automatically. For B, 2b, I have 5.875, so this is 5. 5 is my whole number, and then I have 875 over 1,000. Which reduces to 5 and 7/8. For C, rock music accounted for 0.35 of the total music sales in a recent year. Write this decimal as a fraction in simplest form. So I start with 35 over 100, which is going to simplify to 7 over 20. Example 3, write 0.6 repeating as a fraction in simplest form. So I'm going to multiply both sides by 10, which gives me 10n equals 6.6 repeating. I subtract from both sides an n from both sides, so that's 9n equals 6. And then divide both sides by 9. So basically anything with so quick trick. This is actually the way that you do it mathematically. Anything that is repeating is over 9. So for example, 0.42 repeating would be 42 over 99. Like that. So 42 over 99, which would give you 40.424242. It can actually be reduced to 14 over 33. Okay, this trick only works is if the bar is over all the numbers that are behind the decimal. All right, key concept, rational numbers. So a rational number is any number that can be expressed as the quotient a over b, where a and b are integers and b is not equal to 0. So rational numbers contain integers, whole numbers, and natural numbers. All rational numbers can be written as terminating or repeating decimals. So decimals that neither terminate nor repeat, such as the numbers below, are called irrational numbers. So pi is a great example of an irrational number. 8.7877, 8777. The sevens keep getting bigger, so there's no actual pattern. So this is also an irrational number. Example 4, identify all sets to which each number belongs. So I have negative 2 over 6/11. Since that can be written as negative 28 over 11, it's rational. 1.3133133331 is non-terminating and non-repeating, so it's irrational. And 45 is a natural number, a whole number, an integer, and a rational number. Okay. 0 is a whole number, integer, and rational. 1 4/5 is a fraction, which would become 9/5. So this is a rational number. And then 1.41421356 is not repeating, non-terminating, so this is irrational. And that is the end of Unit 2, Lesson 2.